All right, let's begin Unit 4. Before we dive right in, let's take a look at the Boolean type. This variable type right here, the Boolean type, it's either true or false. These are reserved words, special words used to represent this type. This type is the fundamental type for computers because everything comes back to being either true or false. If you look down here, you'll see this is a bitwise representation here for these Boolean values. We have and, or, exclusive or, not operators, and these are expressed as and, or, exclusive or, and not. We won't do the exclusive or, but we will do the and, the or, and the not. This is bitwise operation, which means they're going to represent this Boolean as bits. True is 1. False is 0. There are only two bits. This is what is called a bit-by-bit basis on which we are going to work to find out what the solution is to any sort of Boolean expression that includes the and, the or, and the not. This is if we're doing it with bits. We won't do it by bits, but I'm showing you that this is possible. What's the difference? If you do it by bits, you use one of these, the ampersand, just one, and this is the or. What we're going to use is a logic form of combining these Boolean types. So I'm going to scroll down and we get to see what I'm talking about. So this bitwise operation, what it means is, how do I combine two different statements with this logic operator here? This is the bitwise one because it's 1. And we have the bitwise and we have the logic one. See? 2 and, ampersand for and 1. 1 for bit, 2 for the logic. So these bits that you see here, I'm going to go through this one first, then we're going to look at the logic ones. So on a quiz, I will give you a quiz, and I'm going to ask you to represent, or to reproduce, I should say, the and the or, and the not the exclusive or. So this statement is reading P and Q. So what is P and what is Q? P and Q are any two statements. I could say, for example, P could be today is Tuesday. Q could be it is raining. So this statement would say today is Tuesday and it is raining. Just a combination of these two statements, okay? A joining, a connection. This would say it is Tuesday or it is raining. So one thing here is these two bits gets evaluated with an and. If it's 0, mean it's false. That means it's not Tuesday, not raining. So is it Tuesday and raining? No, false. The way this and works, it's only true, the one representing true, when all the statements that are connected by and are true. If all the statements are true, the and works out to be true. The or is different. When all the statements are false, the or turns out to be false. So what we're saying here is if one statement in the or happens to be true, the whole thing is true. The whole statement that is connected with the or turns out to be true. With the and, all have to be true for it to turn out to be true. The not means negate. Turn a 1 into a 0 or a 0 into a 1. Flip the bits. So P not, it's 0 here, so it's 1 here. It's 1 there, so it's 0 there, and so on. Now, this is not what we're going to be using, but this logic does remain the same. This is doing bits. So on a quiz, I'll give you bits sometimes. I'll give you true or false sometimes. I'll write T and F. And whatever I'm writing on this side, that's what your answer is going to be. So for example, if this was F and F for being false, this would be F. And this would be T and F, and this would be F if I'm doing the and. This is called a truth table. This is called a truth table. And the result over here is what we're going to use in code. We'll see this a lot more as we go through the course, but for now we just want to know that this isn't a connector. We're connecting two statements and we have an outcome. Now we're not going to do bitwise, but these do exist. What we're going to do is the logic ones. And you could tell how the not looks is an exclamation. That's what not looks like. So this is not P and not Q. So let's focus on this one. So here's the and we have a 1, 1. So it's going to be a 1 because remember, and says they all have to be true for it to be true. False every other spot. Okay, once we get a 0. Sometimes people say the and is a multiplication. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is... So anytime you get a 0 with an and, it goes to 0. Or is addition. Anytime you get a 1. Because when you add, you will get a 1 in the answer. So once and 1 turns up in the answer, the overall outcome is a 1. See, if I add these two, no matter how many times you add 0, you're going to get 0. So you can think of this as addition and this is multiplication for bits. It's still true for the true and false. Like if I say true and true, this would be true. If I say true and false, this would be false. This is true though, because remember, for the or, only one has to be true. So if this is true, the whole thing's true. Now, the thing about this is that I'm going to ask you to reproduce this. And it's pretty straightforward to reproduce, but we have to know this very well. The not, the and the or. Okay? So if I ask you to complete this truth table for me, I'll give you two of these, maybe A and B, or P and Q, and X and Y, it doesn't matter. Then I'll give you X and Y, or P and Q, and you're going to have to fill this last column out. Same is true for the or. I'll give you the and the or, exactly as it shows up here. I may change the bits to true, false, or I may leave them as bits, or I may write T and F. There's some rules when it comes to working with the not. Not's very important because a lot of times we think about what's not true as opposed to what is true. So the rule that we're going to see now is called De Morgan's laws. This is coming from something called Boolean algebra, where you can actually distribute and factor. So that's what we're about to see here. That not, represented by an exclamation. Remember, exclamation. This is writing it out in straightforward English so you could see it. Not on the outside, A and B. If I distribute the not, parentheses means to distribute it. If you distribute it, you got to distribute it over all three. And this is how it works. Not A. That's where we got this. Not and. So it's or. Let that one sink in a little bit there. Not and is or. What do you think not or is? And if you were saying and, you are correct. There are only two. It's either and or or. So if it's not and, it has to be or. And then not B. Here's another one. Not A and. Okay, distributing the not or, so you got to be and. Not B. Well, that's going forward for distributing. Sometimes we need to factor. Like if I gave you this, okay? If I gave you this, you want to go backwards to this. So if I factor out a not, factor out a not out of here, I'm left with A. Factor out a not out of and, I'm back to or. Factor out a not out of not B, and I'm back to B. So this is one thing. Now, something strange here. If you have a not A, a double negative, because not is the negation. Not is a negative sign in math. It's equivalent to it. So if I say not A, if I had not A, that'll still be A. Okay? Because, you know, minus a negative 2 is a positive 2. So not gets you the original thing back. So if I were to factor out of something, let's say this was not A here, this not wasn't here, and just A, if I factor out a not, it would be not A left. Because when I distribute the not, I'll get the A back. So we got to be mindful of working with negation, nots. Okay, sliding down. Here's a little program showing you how Boolean could be used. Yes, we could create a Boolean variable. This is the only method we need. We could create a Boolean variable and we could set it to false. And we could do system.out.print B is B, and then B is false. This is a string. Remember, once you put a plus for concatenating, everything turns into a string. So this is going to turn into the string false, but it pay B is false. And then when we turn B to true and we print it again, it's going to say B is true. We could change B from true to false and false to true. And as we move along in this particular unit, unit 4, we'll talk about control structures like if statements, and we're going to talk about loops and all the different types of control structures. But for now, we could say that we have an if statement that's coming up, and it says if B is true, do this. And if B is true, do this. Well, B is true here because it turned into true, so it will do this. But since we changed it to false, it would skip this. This is why it's called control structures. There is something about these statements that I spoke of. Remember those P's and Q's before? When I had them in that nice truth table. Let's see. Right here, P and Q. Now, when we start off, we'll write P and Q, or, A and B or something like that. But we must remember those are statements. So I'm going to show you what I mean. Here is a statement. 10 is greater than 9. This is a statement that is a Boolean statement because it's either true or false. 10 is greater than 9 is true. If I print that, it will print true. So look at the print here. It says B is false, B is true. That's what we expected. And then it came down. This if statement ran. It said this is executed. But the other one that said this is not executed didn't print because it was false. Okay? And we'll talk about these if statements in detail. So no need to worry about that. In a second, we'll be jumping into that. But look at this. 10 greater than 9 is true. Because this is a statement. So you see, this could have been P. Now that one's sinking for a second. This could have been P. So maybe we have two of them. 10 is greater than 9 and 5 is less than 4. You see, that's where the Q comes in. So we're going to combine two statements together and see if we could get true or false at the end. That's what that whole truth table was about, because we're going to do this a lot. But for now, we're just getting a peep as to what's going on and how we're going to be writing these codes. So you see here, it says here the if statement. 3 interesting things about that little program. If you're writing an if statement, you don't have to say if this is equal true. You don't have to do that. We're going to talk about that in a second. Once we start writing a lot of code, we're going to do this first, and then we're going to say, no need to do this. And as you look into here, you could see that this is actually a Boolean expression. That's what they're saying here. And so we're going to be doing this quite a bit. Last but not least, we'll touch on something that we will definitely do a lot, and it's called short circuiting. When you short circuit something, what it simply means is if you have an AND, you want to short circuit an AND by putting the statement that is most likely false first. Let me say that again. If you want to short circuit an AND, and I'll go back, you want to put the statement that's most likely false first. Remember how AND works. It's mostly going to be false if you get a 0 in there somewhere, right? If you get a false, it's going to turn out to be false. So P and Q, the most likely false should be in front. Because the minute it sees false and it sees an AND, it doesn't look at the rest of it. It doesn't care what Q is. It's going to be 0. Because true and anything is 0, right? I shouldn't say true, but false and anything is 0. False, right? Because it's a multiplication. It's the same as saying 0 times anything is 0. With OR, the opposite is true. You want to put the most likely true here. So the most likely false here for and the most likely true here. Because the minute it sees a true and it sees an OR, whole thing's true. 1 plus anything in binary is 1, right? Because 1 plus a 0, it doesn't matter what comes after. It's a 1, a 0, we're gonna get a 1. So that's what short circuiting is. So once you start writing code and you have to do short circuiting, it speeds up your code. Because if you have a long expression, You have a number of things that need to be checked, whether this and this, or this and that, or this, and you have a long thing. If you put the right variable first, the most likely false for and, the most likely true for or, then it speeds it up by checking and say, oh, this is false, it's an and, whole thing is false. No need to check all that. Code gets a lot faster, so we'll be doing that. Short circuiting, it says logical and logical or. These are logical. These are ones with two ands, two ampersand, and two ors. The one with one is called a bitwise. That's when you're using the actual bits. So logical and logical or will perform short circuit evaluation of expression. Logical and will evaluate to false as soon as it sees one of its operands as false. So you want it to be first. And or will be true as soon as it sees a true. So put the most likely true first for or, the most likely false first for and, speeds up your code. And that brings us to the end of 4.1.